Are you struggling with real numbers in class 10 maths? Don't worry, in this video, I'll make this entire chapter super easy in just a few minutes. Stay till the end and you will be ready to solve exam questions confidently. Welcome back to my channel, Learn Maths with Vijaya. In this video, we will learn 4 important concepts. Euclid's division lemma, HCF using Euclid's algorithm, prime factorization, HCF and LCM, decimal expansion and irrational numbers. Let us learn step by step. First, what are real numbers? All numbers which we use in maths are called real numbers. For example, 1, 2, 3 and fractions like 1 by 2 and numbers like root 2, isn't it? So remember, real numbers is nothing but rational plus irrational. Clear? So, real numbers are nothing but the numbers which we use in maths are called real numbers. It can be numbers, it can be fractions, it can be root 2, root 3, any number. So, real numbers are nothing but rational and irrational. Moving to the second part, Euclid's division lemma. So now the most important concept, Euclid's division lemma. It simply means whenever we divide a number, we get quotient and the remainder, right? So here the formula is A equals to BQ plus R, where remainder is always less than the divisor. Okay, A equals to BQ plus R. So here the remainder is always less than the divisor. Is always less than divisor. Okay. Clear? Let's take an example. 455 we are dividing with 26. What does it mean? Here Q is the quotient and 13 is the remainder. So remainder should be less than the divisor, isn't it? And this is satisfied. Yes or no? Remainder is always less than the quotient which we got. Now, let us understand the algorithm finding the HCF. Okay, HCF using Euclid's algorithm. So now we use this idea to find the HCF. Okay, so first divide bigger number by smaller number. What you have to do? First you have to divide bigger number by smaller, take the remainder, repeat again, stop when the remainder becomes 0. Okay, so first let us take 225. What do you get? If you divide it, you will get the remainder. See, we can write this as 135 times 1. So you get 90. Again 135, what you have to do? 90 times 1 plus 45. Okay. And again 90 as 45 times 2 plus 0. So finally, now we have to stop because our remainder is 0. So what is the HCF? HCF is 45. Okay, so if you get in the first step itself 0, you can immediately stop. Look at this another example, 38220. When you are doing it with 196 times 195 and you get 0 here, right? So here this shows that 196 divides 38,220 exactly. It's a quick result. So every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which prime factor occurs. Okay, every number can be written as a multiplication of prime factors. So what is prime factorization? Break any composite number into its prime factors using the factory tree or the repeated division. So if we take this example, 2 times 2 times 5 times 7. So here what are we doing here? We are doing a repeated multiplication of prime factors we are using here, right? It's a product of prime factors. HCF is nothing but the smallest powers and HCF is the grid. Smallest powers, HCF is smallest powers and LCM is greatest powers. What does it mean? Product of small powers of common prime factors, and LCM is the product of greatest powers of all prime factors. So the important formula you can remember is always you have to verify. Always check HCF times LCM is nothing but the product of numbers. So remember, HCF times LCM is nothing but product of numbers. Irrational numbers. So now let us, before going to irrational numbers, let us look at the quick worked problems examples. These are the most common exam problems. So find HCF 6, 72, 120. 6 can be written as 2 times 3. 72 can be written as 2 cube, that is about 8 times 9. So I am writing it as 2 cube times 3 square. And 120 in terms of 2 cube times 3 times 5. So here the common primes are 2 and 3. And the smallest powers are 2 power 1 and 3 power 1. So we get the LCM as 6. Similarly, if you take the same numbers LCM, the greatest powers are 2 cube, 3 square and 5 to the power of 1. So the LCM is 8 times 9 times 5. That is 360. So HCF times LCM is nothing but the product of two numbers. Very important. Okay, remember this. And the next one more example. HCF, if it is given the numbers 306 and 657 equals to 9, and find LCM. So what you have to do? First HCF of the numbers and divided by 9. So you get the LCM. Okay. So let us take a real life problem type. 3 bells ring at intervals of 6, 12 and 18 minutes. When do they ring together again? So using the same method, we can find it as they will ring together after 36 minutes. Okay. So now coming to the irrational numbers, and this is a proof by contradiction. Any irrational number can be written in the form of p by q. And p and q are the integers and q should not be equal to 0. The most important proofs in chapter, I'll be showing you root 2, root 3, root 5 are irrationals. A repeated question in the exams again. So in exams they ask proof. So these numbers cannot be written in the form of p by q. Okay, any irrational number cannot be written in the form of a p by q. Remember. So as they ask proof, the method is very simple. First you have to assume it is irrational. What is the first step? You have to assume it is irrational. Step 2. You will get contradiction. Step 3. So it is irrational. See, why I am taking so much time for the concept is concepts are very important. If you are perfect in the concept, you can do any problem. So let's focus on the concept. So just one line to remember. Assume contradiction and hence proved. Okay, remember this one line and follow this method. So assume root 2 is equal to p by q and p and q are co-prime integers. Okay, then 2 equals to p square by q square. So p square equals to 2q square, isn't it? If you send p to this side and 2 to this side, you will get this. How do you do it? 2 equals to p square by q square. Q square times 2, you are sending this to the other side, division will become multiplication, equals to p square. So q square, 2q square equals to p square. Got it? This is the same step. I have written directly here. So p square is even, so p is also even. So p equals to 2m. Clear? So then 2m whole square equals to 2q square. 4m square will become 2q square and q square will become 2m square. If you don't understand any step, you can ask me in the comments. I'll explain you again. So q square is even. Again it is the meaning that q is also even. But then q and p are both even. So the contradicting our assumption that HCF of p comma q equals to 1 and the root 2 is irrational. So you can go with any method. This is one of the method which I am using. The same way, try root 3 is irrational using the same method, and if you get any doubt, ask me in the comments. Coming to the decimal expansion. This is the final concept, decimal expansion. This is very easy, and the key rule is if the denominator has 2 and 5, decimal will terminate. Okay. If any other number, decimal will repeat. Okay. So very simple. If the rule is if denominator has only 2 and 5, decimal will terminate. If any other number, decimal will repeat. Okay, for example, you can take 1 by 8, it's terminating, right? 1 by 3, repeating. So let us discuss one by one in detail. Terminated decimal means the decimal terminates, that is, decimal ends if and only if the denominator q has only 2's and 5's as a prime factors. Okay, like 2 power n, 5 power n. Best examples I have taken 13 by 8, it's terminating, and 7 by 20, again terminating, 3 by 125, terminating. Non-terminating means the decimal repeats if the denominator has any prime factor other than 2 and 5. If you take 1 by 3, what do you get? Okay, let me show this to you. 3. You cannot do it, so 0 point, you get 0. And 3 times 3, 9 again. So it repeats. Okay. In the same way for 1 by 7, it repeats. 2 by 11. So this is how it repeats. Denominator has any other prime factor other than 2 and or 5, it repeats. How to decide? The quick test. Reduce p by q to the lowest terms. Factorize q completely. Okay. If q has any other prime factor, it is non-terminating or repeating. Okay. Try this example and let me know in the comments. So let us do the important exercise problems. Okay. Important exercise problems, we'll do this in the part 2. Okay.